Hey guys, I hope that you can hear me. I'm waiting to see myself. Okay, how's it going, guys? How was today's contest? I hope you've all had a good contest today. Can you all hear me? Okay, good. I'm sorry, guys. Initially I didn't want to stream this contest. I mean, I was not at home. I just came home just 3 or 4 minutes ago. I asked someone else to do it, but they couldn't do it as well. So I decided that I do it myself. I read the problems in the path and I said that this is going to be better than nothing. So right now I think I have solutions for A to D. I read them and I thought about them. I have solutions, and for the rest of them we will get the solutions together as well. I mean, during the stream we will come up with the solution. So I hope that, maybe we can just solve. Let's see how many problems there are. I think maybe we can solve up to E or F. So shall we start? Are you guys ready to start discussing the problems? Stuck in C, D, to solve. Okay. If you're ready to start, use this emoji, this 100 emoji. Or any other random emoji that you want. That's okay. Okay, so nice. So I think we are ready to start. Let's talk. Good. There are good creativity in the chats. So let's start talking about the problems. Let me bring problem A. Any creative emoji that came to your mind, you can put it in the chat. I mean, this is getting interesting. Let's talk about the problems. The first problem is a gift from the problems. It says that what is a gift from This is not that much important. It says that integer we have an array A of length n, and we have an array A of b and c based on A, and we have an array A of b and c based on A, and we have an array of b and c based on A. And the score of A is defined as the score of A is defined as the maximum of all the maximum, and you can shuffle the elements the maximum, and you can shuffle the elements the maximum, and that is the maximum score that we can get. But in this problem we can mention that initially C1 and B1 are the same. So about the first element, we know that C1 and B1 are both equal to A1 because the first prefix only consists of the first one. So C1 minus B1 is always equal to 0, and the differences are only from the second index, C2 minus B2, C3 minus B3, and so on. And since we want to maximize it, we can just put the minimum in the first index. We can put minimum at A1 and maximum at A2. If we do this, if we put the minimum as A1 and A2 as maximum as A2, then from 2 for each I, from 2 to n, Ci minus Bi is equal to maximum minus minimum, which is the maximized possible value. This is the maximum difference that you can possibly get. So we will rearrange the numbers, and in a way that the first number will be the minimum one and the next number will be the maximum one. About the first difference, we know that it is always 0, but this way from the second one forward, they are going to be the maximum value they can ever be. So this is going to be always the maximum possible answer. So if you look at it for example, here we have 5, 7, 6, and 5. Here we can put 5 at the beginning and then 7, and then 5. Here we can put 5 at the beginning and then 7. If you have 5, 7, 6, C1 minus 5, then if you have 5, 7, 6, C1 minus 5, then if you have 5, 7, 6, C1 minus 5, then if you have 5, 7, 6. The answer in general is going to be n minus 1 times maximum minus minimum. You can see that what is the difference between maximum and minimum and multiplied by n minus 1, because for each I from 2 to n, this value will be calculated and summed up. So it's going to be n minus 1 times maximum minus minimum. And in here you see that, for example, n minus 1 is 0, so it's 0 times. And in here you see that, for example, n minus 1. In here we have 2, n minus 2 times max. Here we have 2, n minus 2. In here we have 4, which is n minus 1. In here times we have so more, which is n minus 1. In here times we have so more, which is n minus 1. In here times we have so much. Is it clear? Does it? Oh shit. Echo. Come on. Is it clear now? I mean, is my voice clear now? It is weird that why at the beginning we didn't have echo, but right now we are having echo. Okay. No, the point is that, my laptop is mute, but the point is that my web page, in my web page, in here I should also mute it. So I don't hear I don't hear anything about this page, but in here also I should mute it, because for some reason you will hear it when it is not mute, even though I do not hear it. It's weird. So I have to explain from the beginning then. So I'm sorry for what happened right now. I will explain from the beginning. Okay. So let's go over it once again. And from when it has started to have echo, guys, because the last time that I was talking here, no one said anything about echo. From when I started explaining this statement, or maybe from when I went to laptop. Okay. So the main point is that in this problem, I was saying that C1 is always equal to B1, which is equal to A1, and therefore C1 minus B1 is always 0. C1 minus B1 is always equal to 0. But from the next elements, if you consider from the second prefix, you can always put A1 as minimum. You can put the minimum as A1 and the maximum as A2. You can set the minimum as A1 and maximum as A2. And then from the second one to NCI minus BI is going to be maximum minus minimum. And if you do this, your answer is going to be n minus 1 times maximum minus minimum. So basically, at the end, what we have, for example, in here, n is equal to 3, n minus 1 is 2, times maximum minus minimum, which is 2. In here, n minus 1 is 4 times maximum minus minimum, which is 1. It's going to be 4 times 1, which is 4. So basically, we put minimum at the first place and the maximum at the second place. And then when we do this, when we put the minimum at the first place and the maximum at the second place, then from the second prefix forward, all the Ci minus B's are going to be maximum minus minimum. The maximum elements of the whole array minus the minimum elements of the whole array. Therefore, this is going to be n minus 1 times maximum minus minimum. But C1 minus B1 is always equal to 0. and this would never contribute anything to the answer. Is this problem clear? If you are okay with that, please put a plus here in the chat or use this emoji. Let me also, I should check the chats more frequently, I think, because of this issue. Okay. Nice. Nice. Yes, yes. A and B are a bit on easier sides. That's right. So then, if you are completely okay with this one, let's move on to the second problem. Problem B. Problem B, minimize oneness. It says that for an arbitrary binary string T, let f of t be the number of non-empty subsequences of t that contain only 0, and g of t be the number of non-empty subsequences of t that contain at least one. Sorry. Note that for f of t and g of t, each subsequence is counted as many times as it appears in t. For example, f of 0, 0, 0 is 7. So, I mean, this 0 is different to this 0. So, it's important that which indices you will choose. And we define the oneness of the binary string t to be f of t minus g of t, where for an arbitrary integer z, size of z represents the absolute, represents the absolute value of c. Magnitude of z represents the absolute value of c. You are given a positive integer n. Find a binary string s of length n such that its oneness is as small as possible. Well, for this problem, first of all, let's see that what is f of t plus g of t? F of t is all the binary strings that have all zeros, all of them are 0, and g of t is the number of ones that they have at least 1, 1. So what is f of t plus g of t? Exactly, it's going to be 2 to the power of n minus 1. Because it's going to be all of the subsequences. If we add these two numbers together, it's going to be all the subsequences. So it's going to be 2 to the power of n minus 1. It tells us a few things. The first thing that it tells us is that these two numbers have different parities. If one of them is odd, the other one is even. If one of them is even, the other one is odd. So these two numbers have different parities, definitely, because their sum is equal to an odd number. So the first thing about these numbers is that they have different parities. Therefore, the absolute value of their difference is at least 1. Unless n is equal to 0. That's the only case that they might not be equal, which is not the case in here. Because n is at least 1, we have 2 to the power of n minus 1 subsequences, which is an odd number, so these two numbers have different parities, therefore their difference is at least 1. And it tells us that this will be minimized if they will be as close as possible. So if we try to make them as close as possible, we have to make them as close as possible to 2 to the power of n minus 1. The best case is that if one of them is 2 to the power of n minus 1 and the other one is 2 to the power of n minus 1 minus 1. So this is the best case if we can do it like this. And we can simply do it. It's enough. We know that if we have k zeros, f of t will be 2 to the power of k. So it's enough to put n minus 1 zeros and 1, 1. Then we will have 2 to the power of n minus 1 as f of t and 2 to the power of n minus 1 minus 1 as g of t. So my answer is going to be like this. I put n minus 1 zeros and 1, 1 at the end of it, and the end of them. Then f of t will be 2 to the power of n minus 1. Because we know that the sum is 2 to the power of n minus 1, it's better to try to make f of t as equal to the sum divided by 2, as close as possible to the sum divided by 2. If you make it as close as possible to that, then the difference to g of t will be less. So we try to make f of t as close as possible to the average. I mean, it means 2 to the power of n minus 1. We try to make it as close as possible to these values. Therefore, the best case is to put n minus 1 zeros and then 1, 1. Then f of t will be 2 to the power of n minus 1 minus 1, because one of them is empty, and g of t would be that we have this one, and then after having this one, we will choose any of these ones that we want. So we'll have 2 to the power of n minus 1 ways for them. So this way the difference will be exactly 1. This minus 1 is because the empty sequence will not be calculated. Okay, so the point is that we know that the sum is around 2 to the power of n. It's 2 to the power of n minus 1. So we want to make f of t as close as possible as the sum half. I mean the sum divided by 2. We want to make it as close as possible to that. So it's the best if we make f of t equal to one of these two values. And to be more precise, if we have k zeros, we have 2 to the power of k minus 1 possible subsequences with all zeros, because they are non-empty, so we have this minus 1. So we put n minus 1 zeros and 1, 1 at the end. And this is going to be our answer. Is this one also clear? You do not need to calculate anything. In this problem, it's just enough to print the final results. So when you have 1, you just print 0. When you have 2, you print 0, 1. So it's just enough that when you got n, you print n minus 1 zeros and 1, 1 at the end. You do not need to count anything. You just need to print the final string that you're going to have. Therefore, it's going to be okay. Okay. Is it completely clear? The potential rating of this problem maybe is going to be 1100 or so. 1100, for example. Okay, nice. So now let's move on to the third problem, problem C. If you are completely clear, if this is completely clear for you. Problem C. Well, this problem says that you have n zeros and ones, and you have two players, Alice and Bob. They will play in a way that, I mean, they will put and or between these values that we have. We have n values, there are n minus 1 spaces between them. Each player puts an and or an or between two consecutive characters in these n minus 1 steps, so the game will take n minus 1 steps. First Alice plays, then Bob, then again Alice, and so on. At the end, Alice wants the final answer to be 1, Bob wants it to be 0. And you have to say that if both players play optimally, does Alice win or not? Does Alice win at the end or not? And we know that and has, I mean, in this problem, we know that and has greater priority compared to or. So first, I mean, when we want to see that, to evaluate the expression, we say that if there is an and, first we see that we calculate the and of those two values. And whenever we didn't have any ands anymore, then we calculate the or of all these values. So and has greater priority compared to or. First ands will be evaluated. So they play in turn. First Alice plays, then Bob, and they alternate. And Alice wants to make this string to be, make the final evaluation to be 1. Bob wants it to make it 0. So let's have some observations. In order to solve this problem, first we try to have some observations. The things that we can say in here about our answer. Well, first of all, Can you say that? I mean, is the statement clear? Did you guys all understand the statement? If anything is not clear in the statement, let me know. I'm just asking because you said it's tricky. So we have just some zeros and ones, something like this. Two players are playing. Alice puts or. Each one of them puts or and or and. They can either use or and they can put between two characters. There is going to be exactly n-1 steps in this game because there are exactly n-1 spaces in between. They want to do it in a way that at the end, when Alice wants the final answer to be 1, Bob wants it to be 0 at the end. And when we are evaluating the final answer, it's gonna be ands are gonna have the greater priority compared to ours. Okay, so there are several observations that we can have. The first observation, let me first maybe move this part somewhere else. I'm gonna write some observations. First of all, let's start from the easy observations. First of all, Alice will always use or. It's not possible that Alice will use and, because it's always more optimal to use or. I mean, Alice wants to make the final answer equal to 1, right? Alice wants to make it equal to 1. So it's always try to make as many ones as possible. I mean, or is always at least as good as and. So x or y is always greater than or equal to x and y. And the point is that it either has the same answer, or instead of making a 0, we will make a 1. So either it does not change it, or if it changed it, instead of making a 0, we are going to make a 1. And if that happens, we know that this making 1 will never have a harmful effect. Because by having more ones in the next scenarios, again there will be more chances to have the next character as 1 as well, and so on. As we go forward, there will be always more chances to make more ones. So the first thing that we can say is that there is no harm for Alice to try to make as many ones as possible, because whenever we have a 0, if instead of it we have a 1, the final answer is going to be greater than or equal to what it could be otherwise. So Alice will always use or, so that it will have more chance to make ones, and Bob will always use and. Let's say use and. So these are the first things that we can say in this problem. And then what else I can say? I mean, I'm just doing some observations. I'm not necessarily saying that these observations are gonna be helpful or not helpful or anything. Just when we face such a problem, we need to try to make as many observations as possible. I mean, we have to see that, we have to get intuition of what is going on in this game. We should have a clue of that what is going on in this game. And what are the things we can say? We have to gather some facts. So we know that first Alice will always use ors, and Bob will always use ands. And then, if in our array the first element is 1, Alice can put an or after it, and the final answer will definitely be equal to 1. So the next observation is that if the first elements, if the first or the last one, so let's say if a1 equal to 1 or an is equal to 1, Alice will win. Alice wins. Because she can put an or right after, right between this single one and the rest of them. And since and has greater priority, first of all, ands will be executed. And then at the end, we will have several ors. At the end, we will have several ors in the middle. And when we have several ORs, if only one of them is 1, the resulting value will be 1 as well. And since here we have a 1, the results will be equal to 1. So if A1 is equal to 1 or AN is equal to 1, Alice will definitely win. Do you agree with this? If you agree with this part, please put a plus or use this emoji so that we will continue. So based on our observations, so far we know that Alice will always use ORs, Bob will always use ANDs, and then if A1 is equal to 1 or AN is equal to 1, Alice will win. Why? Yes, sure, I will explain it again. Why Alice will win? Because the first element is equal to 1. As soon as the first element is equal to 1, Alice can put an OR after this one, and then when you have a 1 in one side of OR, the result will always be equal to 1. Especially because, it's important that ANDs have greater priority than ORs. So first of all, ANDs will be calculated. First of all the ANDs will be calculated, and all the results will be ORed with each other. We will calculate the OR of all the results to each other. So we will have several values at the end that we have to calculate their OR at the end. And we know that one of them is 1, so the answer is going to be definitely 1. The point is that at the end we will have several blocks. What we will have at the end is looks like this. We are going to have several blocks such that in each block we have ANDs, and between these ANDs there are ORs. So is this block or this or this or this, and inside each block there are ANDs. And the point is that only if one of these blocks is 1, only if one of these blocks is 1, if Alice can make one block of 1s, then she will win. One block that evaluates to 1. If Alice can make only one block that evaluates to 1, Alice will win. So if you look at it, at the end you will have several blocks that they are calculated, their AND will be calculated, and they will be ORed with each other. I'm keeping using OR as a verb, but I'm not sure it's a good thing. But anyway, so you have several blocks that you are calculating OR of them, and inside each block you have ANDs. And if only one of them is equal to 1, your answer is going to be equal to 1. Is it clear now? Can you give an example? Yes, sure. For example, let's say that, what I'm saying is that, at the end, assume that you have something like this. At the end, you will put some ANDs and ORs between them, right? You will have something like this at the end. And I'm saying that, first of all the ANDs will be calculated. So you will have some blocks based on your ANDs. For example, you have this 0 and 1. You have this 1. You have this 1 and 0 and 0 and this 1. So inside each block, you will have several blocks. In each block, you have several ANDs. And at the end, you will calculate the OR of all these blocks, all the values of these blocks. So you will have several blocks. Inside each block, you will have ANDs. And at the end, you will calculate the OR of all these blocks, the results of all these blocks. So this is how you will find out the final answer at the end. And the point is that if only one of these blocks is equal to 1, for example, here this block is 0, this block is 1, this block is 0, and this block is 1. When at least one of them is 1, OR of all of them is going to be 1 as well. So it's only enough if only one of the blocks is equal to 1. If one of the blocks is 1, we're done. So first of all, I said that if A1 is equal to 1 or AN is equal to 1, Alice wins because Alice can make a block of 1. Alice can just split the first or the last index from the rest of the array, and she will have a single 1, which is a block of 1, so the final answer is going to be 1. The next thing is that if we have some I such that AI and AI plus 1 are both equal to 1, then again Alice wins. Why? Because I'm saying, as I said, Alice's strategy is going to be to make a block of 1. So the point is that if this happens, Alice again has the chance to make a block of 1. Why? Because we have two adjacent ones in this case. Alice first can split it from here, put an OR from here, and then Alice will have two parts that Bob in the next step can remove one of these ones, but at least in one of these two parts in the next time, at least in one of these two parts, you have the first element, or the last element as 1. So the point is that if you have two adjacent ones, if you split from there, if you put an OR between them, so you then after that you're gonna have several blocks here and then several blocks here, if you split it from there. The point is that the next time Bob will do one action, either on this side or this side. Without loss of generality, assume that Bob does his action on this side. So the point is that next time Alice can choose the parts that Bob did not do an action and then split this one completely from the rest of array. This way, again, I mean, we had an OR here and we can also have an OR here. This way, this way again we have a block of 1, and at the end when we calculate the OR of all the blocks, it is gonna be 1. So the point is that if we have two consecutive ones, again Alice wins. Is it clear? So far, if it is clear so far, please put a plus or use this emoji as you're using it. If it is completely clear, please put a plus or use the emoji. If you only find, I didn't understand your question. Well, what do you mean that it's incorrect? So far we have two conditions. I haven't talked about the rest of it yet. But so far I'm just saying that if you have two adjacent ones, if the first element or the last element is 1, or you have two adjacent ones, Alice will win. So far I've just said this. If we have two adjacent ones, Alice in the first step can put a 1 between these two, can put an OR between these two, and then Bob will do an action on one side the next time. Then Alice can choose the other side and split this one from the rest, and then again Alice will win. And then the last part I want to say that else, I mean, if none of these two happens, A1 and AN, none of them are 1, and each two consecutive elements are not both 1, else I want to say Bob wins. How do I say that? I say that, I mean, each time, I mean, what Bob does will look like this. I mean, again, when I thought about this problem, I was looking at Bob's actions like removing one of the ones. I mean, Bob each time uses AND, as I said, and he will, if he can, he will use this AND between a 0 and a 1 to remove this one. I mean, because using it between two zeros has no effect. I mean, we lose a 0. We have to either use it between two ones that a 1 will be lost, or between a 0 and 1 that a 1 will be lost. So each time Bob will use a 1 and an element next to it to remove one of the ones. So each time Bob has the ability to remove one of the ones. Bob each time has the ability to remove one of the ones. So the point is that however Alice plays, I want to show that Bob will always make each of the blocks. I mean, initially we have only one block. Is all of them. It is all the numbers. But each time Alice split it from some points, put an OR between them, and then this part and this part will be solved independently. So initially all of them are in a single block, but each time Alice splits it from the middle, and then we will have two parts, and this one part turns into two parts. So the point is that in this situation, when we have these cases, I want to show that all of these blocks that we're gonna have, in all of these blocks, these conditions will never hold. I mean, we still don't let two consecutive ones or let the first or the last element to be one. The point is that after Alice's action, because we know that Alice will never do an action between two ones, it's either 0, 0 or 0, 1 or 1, 0. For example, assume that it is 0, 1, because we do not have 1, 1. So after this operation, there would be only one block that one side of it we have 1. So after this action for Bob, there will be only one block that on one of its sides we have 1. So in the next time, Bob can easily just remove this one. Bob can choose, Bob can use this one and the one next to it, and then remove this one this way. So the next time Bob can just do this, use this one and choose with the 0 next to it. Then next to it is definitely 0, because we said that we do not have consecutive ones. Bob can easily remove this one. So in the next time, still we do not have two consecutive ones, and still there will be no one in any of the sides, at the first point or the last point. So it would be true. And if Alice's action was between two zeros, also Bob can do anything. Anything that Bob would work. So there wouldn't be any issue. Bob can AND any two indices that it wants. So anyway, Bob can make sure that in none of the blocks we have this condition. So if initially we don't have this condition, Bob never lets this condition to happen for any of the blocks. So when at the end we are calculating the OR value of the blocks, we know that in each block the first and the last elements are 0. In each of the blocks, the first and the last elements are 0. Therefore, none of them are 1. The AND value of all of them is 0. So all of them at the end will be 0. So Bob will win. So Bob's action is very easy. Each time we know that Alice can make only at most 1, 1 at the first point or the last point, and Bob next time will remove that one. Yes, 0, 0, 1 gives Alice the win, because if it is 0, 0, 1, Alice can put an OR here, and whatever Bob does, for example, Bob puts an AND here. Then it would be 0 or 1, which is 1. Can you draw around for 0, 1, 1, 0? Exactly, yes, sure. 0, 1, 1, 0. If it is 0, 1, 1, 0, as I said, Alice will win. Why? Because there we have two consecutive ones. How Alice would win? I said that Alice would put an OR here. So Alice puts an OR here. This sign is for OR. I mean, wherever I put this is OR, and this sign is AND sign. Wherever I put this, it means AND. So Alice puts an OR here. So then we have these two blocks right now. Next time, Bob can only do something with one of them. Bob either puts AND here or puts AND here. So for example, assume that Bob puts an AND here. Then the point is that Alice can choose the other side and put an OR here. Then the blocks will look like this. 0, 1 is the first block, this 0 and 1, then this 1, and then this 0. So we have 0 or 1 or 0, which leads to 1. So in this case, Alice would win. Again, for example, another example. Assume that we have this. Now let's consider an example that Bob would win. I wanna give a strategy for Bob to win. I said that I don't want, Bob never wants to let Alice to make ones at the first or the last element of the block. Bob wants to make sure that in each block the first and the last elements are 0. Because it's if the first and or the last element, if one of them is 1, then that would be problematic. Alice would win afterward. Alice can win with one action. So whenever Alice makes any of those ones at the beginning or at the end of a block, Bob will remove it immediately. This is the strategy of Bob. For example, assume that Alice first puts an OR here. So we will have, after that, we will have 2 blocks. We have 2 blocks here to the left and to the right of this point. Then Bob sees that there is a 1 here. So in the next action, Bob takes AND of these 2 elements, this 0 and 1. When it takes the AND of these elements, it's like it's removing this one, because 0 and 1 is gonna be 0. I mean, 1 has no effect on AND, so whatever, I mean, you have 1 and anything, that 1 will be removed. It's like that 1 will be removed and the other elements will stay. So Bob will remove this element. Then Alice puts an OR here. Then Bob puts an AND here and remove this one. And then assume that, for example, Alice puts an OR here, then Bob can do anything in this situation, any random thing, because no 1 has been made. So, for example, Bob will remove this one, puts an OR here, and here. And then Alice, for example, sorry, there was a 0 in here as well. I forgot to put 0 here, because the last element was 1, but it must be 0. The last element was 0, as I said. So again, the next action, for example, Alice uses this one, Bob will remove this one, puts an AND here and removes this one. Again, Alice chooses this one, Bob will remove this one, and so on. So each time Bob tries to remove ones at the beginning or at the end of a segment, and this way the answer will be calculated. Is it completely clear? Again, please, if it is clear, again use this, use the emoji or put a plus in the chat. So the answer is very easy. We just see all the cases. If you have 2 consecutive ones, the answer is Alice wins. The answer is yes. Otherwise, the answer is no. What is the potential rating for problems here? I don't know. Maybe I'm just guessing. I mean, I'm not sure it's correct or not. But I guess maybe around 1400 or 1500. Guys, this t-shirt is a bit large for me. It's X large. I mean, this shirt is not my team's shirt. We swapped our shirts after the contest with one of the contestants. I swapped my shirt, and this t-shirt is a bit large for me. And yeah, I'm just always trying to fix it during this year. Maybe next time in ICPC you will be given around 3 or 4 t-shirts of the contest, and I changed one of them with one of the members of another team. Next time maybe I have my own t-shirts on. Okay, nice. This was a Russian team. I think I don't know the complete name of the university, but it was a Russian team. So let's now move on to problem D then. If you completely understood the solution to problem B, to problem C. So let's move on to problem D. Problem D says that you have a permutation P of length n and have a string S of length n containing only characters L and R. And you want to sort this permutation. And each time when you have these characters of L and R, if an index I, S of I is equal to L, you can swap Pi with P of I minus 1. If S of I is R, you can swap Pi and Pi plus 1. Okay. So in your permutation, you can, I mean, based on if it is L or R, you can swap elements number I with the element to its left or to its right, based on if this character is equal to L or R. And you have to say that if you using these operations, you can sort the permutation or not. You have to answer that if you can sort the permutation using these operations or not. And you have Q queries. In each query, you will select an index I and change the value of Si from L to R or from R to L. I don't know why or from R to L is written in the brackets. I mean, it's a bit ambiguous. But anyway, you can change it, either L to R or R to L. And the changes are persistent, but the swaps that you will do in P are not persistent. I mean, each time P will be reset to its original form. So you have to say if you can sort the permutation P using these operations, or you cannot sort the permutation P using these operations. So again, in here, basically, the point is that you can look at it like you are making, let's say, several connections. You have, I mean, to consider two consecutive elements, I and I plus 1. I mean, they are either connected to each other or they're not connected to each other. What do I mean by connected to each other? It means that either I plus 1 is L or I is R. If at least one of these two happens, these two will be connected, otherwise they are not connected, right? So if this is L and this is R, then it means that we have a block here. These two are not connected. So consider all the blocks that we have. I mean, consider that these are the pairs that are disconnected from each other. I mean, we have these blocks, and each one of them, I mean, it means that this element and this element, this is R, this is L. So they cannot get to each other. We only care about the two consecutive elements such that the first one is R and the next one is L. Whenever we have this R and then an L, it means that there is a block here. There's no way that we can swap these two elements. And it means that all these blocks have no way to connect to each other. The point is that this block is completely independent from this one, completely independent from this one, completely independent from this one, and so on. So if you consider each of these red lines, whatever that is to the right of this red line will stay at right of this red line, and whatever is to the left of this red line stays to the left of this red line. So if you consider all these red lines such that to the left of them there is an R and to the right of them there is an L, whatever that is to their left stays to their left, whatever that is to their right will, oh come on, why I said yes, LR, sorry, I was assuming that R is blocked, but yeah, LR, sorry. So yes, we have the first one must be L and the next one is R. So whatever that is to the left of these lines, it stays to the left, and whatever that is to the right of this red line will stay to the right. Okay. So this is an important thing. So these red lines are very important. The point is that when we have such a red lines, the minimum elements to the right of this line should be greater than the maximum elements to the left of this line. The point is that the answer is yes if and only if for any red line, the minimum elements to the right of this red line is greater than the maximum elements to the left of this red line. Only in this case, this red line is okay. Why? Why do I mean that the minimum should be greater than maximum? Assume that the minimum of this one, do not forget that this is a permutation. So you have the numbers from 1 to n. Assume that the minimum here, this is a permutation, right? Assume that the minimum here is less than the maximum in here. So I mean, they must be swapped then. This minimum should come to this part, and this maximum should come to this part. I mean, this should come to the right of this one. So something should change in this case. But we know that they are completely disconnected. I mean, there's no way to come from here to here, because each index can only connect to the consecutive ones. But like here, there is a gap that, I mean, no one can pass over this part. I mean, it's like here is blocked and no one can pass over it. So we have several positions that are blocked. No one can pass over them. So whatever is to the right stays to the right, and whatever is to the left stays to the left. Therefore, the maximum here must be less than the minimum in here. Right? So for any red part, this should be true. Yes, we could also check if max to the L is equal to L. Yes, we could also check that. But the point is that when max is equal to mean, the max is going to be equal to this. I mean, max is going to be equal to this I. Let's name it I and I plus 1. Max is going to be equal to I, and min is going to be equal to I plus 1. So you could also check that maximum before the red line is equal to I. It means that all the numbers before it are going to be less than or equal to I. That would also make sense, because it means that if maximum here is I, it means that all the numbers from 1 to I are here, and therefore all the numbers greater than I is going to be to the right of the point. So you could also check that the maximum to the left is going to be equal to I. Yes, exactly. So if you calculate the maximum of the prefixes for any blocked vertical line, you can say that anything to the left of it, must be less than or equal to I. If there are I numbers here, there must be all from 1 to I. Right? And everything to its right is definitely going to be greater than I. So the point is that the main point of this problem in these queries is to just keep track of these block lines. If we can just keep track of these block lines and for each one of them check if they are okay or not, I mean, the answer can be easily calculated. So we're gonna have several variables. Let's have let's have a bad blocks. It stores that how many bad red lines do we have? Let's say bad lines. Let's have a counter that says that how many bad lines do we have. We know that the answer is yes. We can sort if the number of bad lines is equal to 0. So at the end it must be equal to 0 if we want our answer to be yes, if we want to be able to sort them. And whenever something changes, we can just see that if it adds any red line or removes any red line. So for example, when it becomes L, when this becomes L, for example, it was R and now becomes L. The point is that if the previous one was L as well, previously we had this red line, but now we do not have this red line anymore. So we have to remove this red line. And if the next one is R, previously we did not have this red line, but now this red line will be added. So we have to add this red line. So we need to handle two queries. Either add a red line or remove a red line. And when we add or remove a red line, we just first need to check if that red line is good or bad. If that red line is good, then it has no effect. It's not important at all, because it still can be sorted without considering this red line. I mean, no one needs to pass over that line. So that's okay. But if it is a bad line, when you are removing it, you have to subtract the number of bad lines by 1. When you are adding it, you need to add the number of bad lines by 1. So this way you can update the number of your bad lines, and then at the end, if the number of your bad lines is 0, your answer is going to be yes. You can sort the array, the permutation, otherwise it's no, you cannot sort the permutation. Is it clear? About the solution to problem A, if you see the video, at the beginning of the video I explained the solution of A. So if you come here, you can just see whenever of the solution that you want, and you can see problem A. So is it clear? I used a segment tree as a, oh, I see. Yes, it was, a segment tree was not needed on this problem. You can just calculate the maximums of the prefixes, which is like prefix sum. It's just prefix max instead of prefix sum. It's very similar to prefix sum. And then you just consider adding or removing the red ones. And this way the answer will be calculated. So if it is clear for you, again, please use this emoji or put a plus in the chats. Yes, sure, I will have one more recap. I said that there are gonna be several red lines. I mean, there is gonna be several blocked points, several points that we cannot pass over them. Assume that here we have an L and here we have an R. Then we cannot go from here to or vice versa. Then if this happens, everything to the right of these parts must be greater than to everything to the left of these points. So everything to the right of this line must be greater than to the left of this line. So if you consider these blocked points, it will, I mean, if you consider them, in between them, there will be several connected components that each two consecutive ones in each one of them are connected to each other. They can be swapped with each other. So in each one of them, you can reorder them as you want, but you cannot move over here. So whenever you have a red line, you cannot pass over those red lines. And when this happens, you can just say that when you cannot pass over these red lines, you can say that each of these parts must be solved independently. Therefore, whenever you have a red line, you must check that everything to its right is really greater than everything to its left. This must be true. Everything to its right must be greater than everything to its left. And you just check it for every red line. And the question will turn into only just updating these red lines and each time checking if a red line will be added or a red line will be removed, etc. So each time you just need to just check if a red line will be added or removed, and that can be easily calculated as well. When you change one of the cells, you can see that the red lines to the left of it and to the right of it, if they are being added or removed after this, and update them and keep the number of bad red lines. If it was equal to 0 at the end, the answer is going to be yes, otherwise it's going to be no. Is it clear now? I hope that it makes sense now. But maybe I can try to explain again that what a red line means. A red line means that the elements to the left of this index and the elements to the right of this index cannot be swapped to each other. So it means that there is no connection from the left of this line to the right of this line. So we have this array, there is a red line. It means that there is no connection from the left parts to the right parts. Right? So it basically means that. So the point is that if here, I mean to the left of this red line, you have an index that is L, to the right you have an R, it means that you cannot swap those two. And the connection is, there is no connection. If here you have an L and here you have an R, it means that there is no connection between these two, and everything to the left of it will be swapped with each other, and everything to the right of it can only be swapped with each other. There is no connection between an element in here and an element in here. In these cases, we draw a line, a red line in between these two parts. And we say that everything to its left is going to stay to its left, everything to its right is going to be stay to the right. So let's go over the key points once again. Sure. The key points. The first thing was that only we need to find out for each two consecutive indices if they can be swapped or they cannot be swapped. the first thing is to find out if each two consecutive elements can be swapped or cannot be swapped. And then when we find that out, there are going to be several pairs that they cannot be swapped. There are going to be several indices that you cannot swap from there. So it's like you're going to have several connected components that you can say that in each connected components you can swap the elements as you want. But between two connected components you cannot change anything. So for any red line, and any red line says that there is no connection to the left of it, between the elements to the left of it and to the right of it. So there is no connection here, so the minimum value in here must be greater than the maximum value in here. Or the maximum in the left must be equal to I if here we have I. So in other words, everything that is to the left of this red line must really belong to the left of this red line. And anything that is to the right of this red line must really belong to the right of this red line. So they need to really belong to where they are. And when that's the case, we say that this red line is okay. But if that's not the case, we say that this red line is a bad red line. Because somebody wants to change their sides, but they can't because this is blocked. And there's no way to go from here to here. Okay, does it make sense now? Okay, nice. And guys, also for further discussions, if you want, you can join our Telegram channel. Let me send the link here, or join our Discord server. In both of the Telegram channel and Discord server, there are so many people, and you can join the discussions there as well if you want it. Let me share Discord as well. Okay. So okay, what will be the complexity of it? The complexity is gonna be for each query of one, so it will be of Q in general. Because each time we are just gonna do everything of one, we just compare everything to the left of it and to the right of it, and we see if another red line will be added or will be removed. We are just comparing them, and then we update the red lines. If we see another bad red line, we add a bad red line, or we remove a bad red line. So what we do basically is we are handling each query in O of 1. So in general, it's gonna be O of Q. Is it clear? So if you are okay with that, again, please put a plus or use the emoji if you're ready to go to the next problem. Otherwise, let me know if you want to talk more about this problem. Telegram link is sent in the chats. I mean, if you go, it's a bit above your message. If you want, I send it again. Here is Telegram account. I didn't get how they are blocked. Okay, let's go over an example. Basically what we are saying is this. I mean, for example, consider this index. We have an L here and an R here, in here. You know, if you consider this 4 and this 8. For this 4 we have an L, for this 8 we have an R. So the point is that whatever is to the left of this line, let me draw. I can draw a line here. Nothing from the left of this line can ever go to the right of this line. And nothing from the right of this line can ever go to the left of this line. When the characters are like this. When the characters are like this, nothing from the left of this line can go to the right, and nothing from the right of this line can go to the left. So basically, whatever that is to the left stays at the left, and whatever is to the right stays to the right. this is a red line. This means that nothing can go from the left part to the right part, but the rest of the elements can be swapped with each other. For example, because this one is L, these two can be swapped with each other. Because this one is L, these two can be swapped with each other. And because the first one is R, these two can be swapped with each other. Again in here, because this 8 is R, these two can be swapped. Because this is R, these two can be swapped. And because this is R and the next one is R, these two can be swapped. So in each of these two parts, they can be swapped with each other. So they are connected components. They can be swapped with each other as they want. But everything that is to the left of this red line and everything that is to the right of this red line, they cannot be swapped with each other. So whatever that is to the left will be swapped with themselves. Whatever is to the right, they will be swapped with themselves as well. Therefore, we can say that in this case, the maximum in the left part must be less than the minimum to the right part. In here, that does not happen. In here, the minimum here is 3. The maximum here is 5. This does not make sense because this 3 should come to the left of this 5. But it has no way to come to the left of this 5. This part is blocked. There's no connection from this part to the other parts. So in this case, it is not possible. We have to make sure that wherever that is blocked, anything to the right of it is greater than anything to the left of it. Or the maximum to the left is going to be equal to the index of that line. Which is, for example, I. So we have to just update these red lines and see that if they are gonna stay like that. And at the end, if we have no bad red lines, we are just gonna see out yes if the number of bad red lines is 0. Otherwise, we're just gonna answer no. Okay, I hope that I made it clear now. So is it clear? So shall we now move on to problem E? If you want, you can also watch these parts again as you want as well. So as I said, the stream will be saved. After the stream, you can also watch any part you want. All the streams will be saved, so you can watch any part. I have not implemented problem D. But if you want, maybe I can just show you one implementation of problem D. I'm just afraid that we might not be able to solve the next problems this way. So let me just quickly show it and then quickly move on to the next problems. I don't want to spend a lot of time, but quickly I will show the code. For example, this code looks very good for problem D. Let's see what does it do. It gets all the PIs and x is equal to maximum x and pi. Yeah, this is yes. So in this code, he has just processed f of I is equal to 1 if the maximum till index I is equal to I. So it means that everything to the left of this line is in the correct position. If maximum so far till index I is equal to I, it means that these elements are in correct positions. The numbers from 1 to I are really in the indices from 1 to I. So even if there is a red line in here, it wouldn't be an issue. Because everything to the left of it must be to the left of it as well. The maximum till here is equal to I. So this is why f of I says, and B is just turning S of i's from a string to just a Boolean array, and then we have CNT plus check of I. Check of I just checks if there is a line there or not. It says that at position X, we must have an L. We must have an L at X. At X plus 1, we should have an R, and this line must be a bad line. It means that f of x must be 0, or in other words, the maximum till there should not be equal to x itself. And then whenever I will be added, we just say CNT minus equal to check of I minus 1 plus check of I. We remove the previous answer that these two lines had. And when we change B of I, Then we add check of I minus 1 plus check of I again. And if C and T was non-zero, we say out no, otherwise we say out yes. This code has implemented very good. I mean, this is a very neat code. I mean, I really liked it. Let me also share it with you. This was a really neat code for this problem. Let me share it in the chat. I see my camera is stuck. Yeah. This is not good. But I hope that you understood what I mentioned. So is it clear now? I see. Nice. So let's see if my camera is still stuck now. Wait a minute. There's why? Okay. This now makes more sense. So shall we move on to problem E? Problem E is the first problem that I don't have a solution right now. We have to read it together and find the solution. Thank you very much. I hope that you enjoyed it. And guys, if you wanted to support my work, I would appreciate it if you liked the video or subscribe to the channel if you haven't already. And if there's anyone else that you might think that the streams are helpful for them, I mean these solution discussions or the topic streams, please invite them to the streams as well. Let me also send a playlist of our Friday topic streams. Each Friday we have a topic streams that we talk about a topic and we solve problems with them and discuss them. You can find all of those topic streams in here. So far we talked about dynamic programming, graphs, and number theory. If you want, you can watch them here, and each Friday we have one topic stream again. Yesterday we had one topic stream on number theory, for example. So let's now move on to problem E. Problem E. Problem E says that maximize the score, says that suppose we partition the elements of an array B into any number k of non-empty multicells S1, S2 to Sk, where k is an arbitrary positive integer. Define the score of B as the maximum value of max of S1 plus max of S2 plus 2 max of Sk over all possible partitions of B for any integer k. NV is given an array A of size n. Since he knows that calculating the score of A is too easy for you, he instead asks you to calculate the sum of scores of all to the power of n minus 1 non-empty subsequences of A. Since this number may be large, please output it modulo mod, this number. So you need to calculate the score for each subsequence of your number. Let me first see the solution. I think I have some ideas of what we should do. I mean, we can see that. I mean, for example, when we have a number, we can easily see the score. I mean, it's gonna be, we can just, for each prefix, we can store that what is the minimum. I mean, the answer is gonna be the number of zeros plus the minimum of number of zeros and ones plus minimum of number of zeros and ones and twos and so on, if we have it for 1. But let's now first see a solution of someone and see what they've done, and then I will completely explain the whole thing, the whole solution. When will you cover combinatorics? Why my camera keeps stuck? When will you cover combinatorics? I will keep combinatorics soon in the next sessions. Maybe I can cover I have so far talked about combinatorics a little bit in the number theory, but I can talk about it more as well. In Telegram, I put a poll on what topics do you want me to cover each week. You can just, if you want combinatorics, you can vote for combinatorics. You can join the Telegram channel. In there, I will put polls about our topic streams and their topic. So let's see the code of people. Let's see what they've done. So they have so far, let me first see. Do you have I factorial and combinations, I guess, in here? So yes, we go over all the values. Mn is equal to Mn and minimum of Mn and Ai. Total minus equal to Ai. B is equal to KSM of 2. KSM is power. So the rest can be as they want. These ones can be as they want. Okay, the main idea is that we have this force up to Mn, and the point is that if you do all this force up to Mn, your time complexity will be n log n. Because the first time Mn is gonna be at most n, the next time it's gonna be n half at most, then n third, then n fourth, and so on. But G of j is equal to we have this G of j that will be multiplied by SB. Oh, and SB each time will be added by M. Oh. Oh, it makes sense. Yeah. Yeah, I had some ideas similar to this, but it was a bit not implementation friendly. But yeah, we can discuss this solution. Let me first tell you the complete statement again and talk about the full solution again from the beginning. So in this problem, maximize the score. Let's talk about the problem once again. Suppose we partition the problem E, maximize the scores. The score states that suppose we partition the elements of an array B into any number k of non-empty multices S1, S2 to Sk, where k is an arbitrary positive integer. Define the score as the maximum value of max of S1 plus max of S2 to max of Sk. And you are given an array A of size n, and you want to, since calculating the score of A is too easy, you are asked to calculate the score of all the possible subsets of your array. So you have to say that what is the score of all the possible subsets and add them up. So assume that first let's talk about the subtask. Let's start with saying that let's solve that part that was told to be easy. Let's say that we have some array A, A1, A2 to AN, and we want to calculate the score. Calculate the score of our array. But basically, you can say that each of these indices, each of these values can add your score only by 1. I mean, by each value will either add your value, your score by 1, or do not add your value at all. So each value will change your score by at most 1. And basically we can say that if we have several zeros, we can put those zeros into different groups. I mean, assume that we have, for example, 5 zeros. All those 5 zeros can contribute to our answer. All of them can add 1 to our final score, because they can be in different groups, and in each of those groups they can increase our mix by 1. So instead of looking at it like we have several groups and we want to calculate their mix, we try to see that what is the effect of each of these numbers independently. Okay, we want to see the effect of each of the numbers independently. What I said about the contribution of the numbers, that I said it's at most 1, was based on this. I mean, I had to mention it. I had to mention this, that I meant this. I meant that we could just look at it in a way that each of the elements can add at most 1 to our final answer. How? We can just say that when we have a set and we want to consider its mix, assume that it has numbers, assume that its mix is 5, for example. It means that it has 0, 1, 2, 3, and 4. We can assign 1 cost to this one, to this 0. I mean, this 0 contributes 1 to our score. This 1 contributes 1, this 2 contributes 1, this 3 contributes 1, and this 4 contributes 1. This is how, instead of calculating 5 for this one, I will distribute it among these 5 elements, and I count 1 for each one of them. So this is my strategy to counting the answer. I say that I have 5 zeros. I say that they will contribute 5 to my answer. Each of them will contribute 1. And then let's say I have 7 ones. Well, the point is that when I have 7 ones, I can use at most 5 of them. Only 5 of them can contribute to my answer. Because there are 5 groups only that we have zeros in them. And these 5 ones can go into those 5 groups and increase their mix by 1 more. So only 5 of them can add the answer by 1. So from here, again, we get 5. And then assume that we have 3 twos. When we have 3 twos, all those 3 twos can contribute 1 to the answer. And this 3 will be added. And so on. The answer finally, the maximum score that I get will be the sum of these values. So my answer at the end is going to be this. My answer will be equal to the number of zeros that we have that I have, plus the minimum of the number of zeros that I have and the number of ones that I have, plus the minimum of the number of zeros that I have, the number of ones that I have, and the number of twos that I have, and so on. So this is how my answer will be calculated at the end. I mean, this is how I can calculate the score of an array. This is how I can calculate the score of an array at the end. It will be the number of zeros plus minimum of number of zeros and ones, and so on. Because the point is that all these zeros can contribute 1 to the answer, and then these ones, if the number of ones is greater than the number of zeros, those additional ones cannot add anything to any of the. I mean, I have only these many groups. So these ones can only go to these groups and add their answer by 1. But if they are more than that, those additional ones are not going to be useful. And if they are less than that, all of them are, I mean, they will make as many groups as they can. They will contribute to as many groups as they can. So far, do you agree that this is my answer? This is my score if I have only one array. If you agree with that, please put a plus in the chat or use the emoji. Nice. So yes, this is gonna be my score for one array. And now assume that we have more than, we want to consider it for all the subsequences. Well, the point is that I have a for I from 0 to maximum number that I can have. The maximum all the AIs are less than n. All the AIs are from 0 to less than n. And even if they could be more, it was not important because numbers greater than n are not useful. They will not contribute to anything at all. So I can just save that CNT of I can say that how many i's I have. The idea is this: for the subsequences, I want to have a 4 on all the i's and just store that. Let's say that I have something similar to dp of I and j. I will not define exactly dp of I and j, but let's say I define something like dp of I and j, which means that I have a subsequence. I only consider the numbers from 0 to I, and right now I have j open groups. What do I mean by j open groups? I mean the groups that they have everything up to I, and I plus 1 can contribute to them as well. I plus 1 can be added to them. If a group does not have everything from 0 to I, adding I plus 1 to it has no points. So it means that I only consider numbers from 0 to I, and I have j open groups. I have added all the numbers from 0 to I, and I have right now j open groups. Okay. This is my idea, and the point is that when I add the next number, when I add I plus 1, I can fix that how many I plus 1s I will add. I can fix that how many I plus 1s I will add. And then if I fix that, let's say, for example, I add k I plus 1s, minimum of j and k will be added to my answer this way. Minimum of j and k will be added to my answer because j in other words is minimum of CNT 0 to CNT I in that subsequence. J in other words is the minimum of CNT 0, CNT 1 to CNT I. And the point is that when I count it like this, when I plus 1s will be added, if I have ki plus 1s, then minimum of j and k will be added to my answer. Because those can be added to those groups, and this much will be contributed to our final answer. So this is my idea. I have an O of n cubed solution. Why? Because I has n. For I have n values. For j, I have n values, and for k, I also have n values. So far, I can provide an O of n cubed solution, which is not good, definitely not good, but I have an O of n cubed solution. I say dp of I and j, I only consider numbers from 0 to I, and I have j groups. And then I fix that how many numbers of I plus 1 I will add. And then this would be an easy combination. This would be an easy combination. For example, if I have k, it would be CNT of I plus 1, choose k times dp of I and j, dp of I and j was this is the number of ways that we have. Each one of them, we right now have dp of I and j for them, and I will add minimum of j and k to them. Okay, this is the contribution that I have right now, and j and k will be added to them, and the number of ways to choose k out of CNT of I plus 1 elements is this combination. This will be added to dp of I plus 1 and minimum of j and k. So this is the first thing that we can say. In order to optimize it a little bit, the point is that we do not really need to have a 4 on j and also have a 4 on k. We can initially, just have a 4 on minimum of j and k instead of having a 4 on j and having a 4 on k independently. We can just have a 4 on minimum of j and k. We can just see that in how many ways at least we will choose at least k new elements, and in how many ways our dp's are also greater than or equal to j as well. We can see that in how many ways both our second dimension is greater than or equal to j, and we will choose at least j elements as well. I mean these many elements as well. So we can just, let's call it as A. We can just have a for on A and easily see that in how many ways minimum of j and k is equal to A, and we do not really have a for on that. And also the other point is that when we have dp of I and j, j is always less than or equal to n divided by I. J is always less than or equal to n over I. So the total number of cells that are useful is going to be at most n over 1 plus n over 2 plus n over 3 and so on to n over n. This is equal to, this is from O of n log n, or theta of n log n. So in general, the first two dimensions are not really n squared as well. This is n log, and if we remove I from the dimensions and only work with j, and each time only go over the j's that are useful for us, then it's going to be n log n, not n squared. And if you take a look at this code that I will send in the chats now, this code has implemented it very well. Let me share my screen as well. If you look at it, initially he has just calculated all the factorials and all the inversions, and he also has these functions. This is for combination, this is for power, and also some modulo mod. And he, each time, first, when he gets the numbers, he just adds a of k by 1 when he gets a k. A of k is that how many k's we have. And he has a for from 0 to n. Each time he says that mn is equal to minimum of mn and a sub I. And he says that tot minus equal to ai. I mean, by doing that, tot is short for total. Total, it means that how many numbers are left that are greater than or equal to ai. So tot means that how many elements are greater than ai. ai's are being removed from here. Tot initially n, each time when we go over a number, it will be subtracted by ai. So it is the number of elements that are greater than a sub I right now. And mn is the minimum number that we have between 0 to I. And we know that mn is always less than or equal to n over I plus 1 when we are on I. When I is 0, mn is at most n. When I is 1, it is at most n half. When I is 2, it is at most n third. When it is 3, it's at most n fourth. Therefore, when we have this second 4, it's not going to be n squared. N squared will be time limited, because n is up to 2 times 10 to the 5th. But this is going to be n log n, because this is going to be at most go up to n over I plus 1. So he also has the number of ways to choose some of these elements. It's going to be 2 to the power of a sub I minus 1. In total, we have 2 to the power of a sub I ways to choose some of these numbers. And the point is that he just says afterwards, I mean, he's considering the cases to add this number. I mean, he's fixing all the ways that the greatest number that you have in your subset is gonna be I. So he has to consider 2 to the power of a sub I minus 1 ways in total to add some i's to your array. And then he has a j from 1 to mn. He fixes that what is gonna be that value of j that I was talking about in here. He's talking about what the value of j that I was talking about in here. So he says that g of j, which is that dp of j that I was talking about, multiplied by sp is the number of ways to choose some of these ai's. It says that g of j will be multiplied by sp, I mean the number of ways that it will really stay as j, and the rest plus equal to g of j times 2 to the power of tot. I will explain that what it makes sense. I mean, you have to understand all these 3 lines together. I mean, you cannot understand these lines one by one, because in order to understand this, you need to understand what is going on sp, what is happening on sp. So then you update rest, and then you update sp. First of all, let's talk about what is happening to sp. If you look at it, each time from SB, he is subtracting, he said plus equal to mod minus this combination. So it's like he's subtracting the number of ways to choose J of these AI elements. So it's like each time he wants to just keep the number of ways to choose more than J elements. It's like he has all the ways in SB at the beginning, but each time he's subtracting the number of ways to choose J of them. Each time he's subtracting the number of ways to choose J of them, so that afterwards he has the number of ways more than J. Whenever we are on J, SB is the number of ways to choose at least J of these. So the point is G of J, when we are on G of J, we need to make sure that we have at least J. We have at least J of this element. So G of J will be equal to G of J times SB, which is the number of ways to choose at least J of these AIs, J of these I's. And then rest will be plus equal to G of J times 2 to the power of totes. 2 to the power of totes will be multiplied because we have also totes numbers that are greater than this number, and each one of them can come or not come, and this must be calculated in all of those ways. They are not processed yet, so I have to multiply 2 to the power of totes. And this way everything will be calculated and we have the final rest at the end. Does it make sense? Is it clear for you guys? This t-shirt is making me sick, really. It's so hard to fix it once every minute. So, do you have any questions about this problem, E? Do you guys want to discuss problem F as well or not? I haven't read problem F so far, but if someone really wants that, we can talk about F as well. I haven't read problem F so far, but if you want, we can try to understand it together and hope to figure it out. It's tough. You're talking about E? If any part was not clear, let me know. I can explain it again. Basically, I mean, we had just this dp of j, or as we saw in the solution here, in the solution that was implemented by this user, we have this g of j, and g of j means the number of ways such that, I mean, we have chosen all the numbers from 0 to I. We are only processing numbers from 0 to I. And in these numbers, we have right now J open groups. J groups that they're gonna have, I mean, we are assuming that we want I, we are considering the number of ways that I will contribute to J groups. And in order to do that, we need to at least choose J I's. And also the number of groups must be previously J as well, at least J as well. And moreover, when we have this, then we know that these J I's will contribute to our answer. So our answer will be added by these I's, by these numbers. So basically, I'm trying to see that how much each value will contribute to my final answer at the end. And I'm trying to understand that the main idea that is going to be very useful in this problem, that helps you to solve the problem, is that this j is at most n over I. And this is going to be helpful because it shows that if you have 4s on all the possible value of j, it's not going to be n squared. It's not going to be n squared. It's going to be n log n. And this is very important. So I hope that it makes sense now. So guys, yeah, as I said before, today I didn't I didn't know that I can do this stream. I initially was thinking that maybe I cannot do the stream, but because no one else could also do the stream as well today, I decided to somehow just get home as fast as possible and just solve some of the problems. I assume that it's going to be better than nothing. I hope that it was useful and you understood the solutions that we've discussed. And let me know that if there's anything needed. I again want to invite you to also attend our topic streams on Fridays, where we're gonna discuss all the topics. Also, you're more than welcome to join our Telegram or Discord server. We have communities for competitive programmers. If you want, you can join our Telegram channel here and our Discord server here. You're more than welcome to join there. And if you want, join our topic streams as well. In all of them, I would be definitely happy to see you there. I hope that this stream was helpful. We're gonna also have another stream tomorrow. Tomorrow is another contest, and therefore we're gonna have another stream as well. I hope that is gonna be useful for you guys too. So if everything's clear, then I'll see you guys tomorrow. Do you have a question? Bro, when I try to solve moderate level question, then I don't get the logic. I feel like I can solve, but I'm not able to reach optimal solution. Let me know how much time I should give to a question. It's better if you don't set a fixed time for a problem. That's how much you want to think about. As it is said, I also invite you to watch the interviews that we had. We had interviews. You can see the interviews here in the channel. We have interviews with CP legends. For example, Arash has II Gold and Silver. Umnik is a well-known person. You know Umnik, definitely. He's in top 10 of CF. He's a legendary grandmaster. Alireza Kaviani is the first legendary grandmaster from Iran. He's a legendary grandmaster and the II Gold and Silver medalist. Also, Adamant, the organizer of OCPC, and Ors is IMO Gold medalist. These guys are all very well-known competitive programmers, and I talked with all of them about these things. Many of your questions are answered in these interviews. Let me send it. If you want, you can watch them. As we said and talked with all of these guys, it's better if you don't fix a set time for each problem. Try to think as long as you have any idea. As long as you have any idea, try to think about the problem. And whenever you thought that you will feel it. You will feel it if you are progressing or you're stuck for a long time. If you still have idea, try to still continue thinking. But if you feel that you're stuck and you don't have any idea anymore, it would be completely okay to look at the solution. Maybe it's enough for you to read one line of it. Maybe it's enough to read half of it, and maybe you want to read all of it to understand. It's completely okay. You're gaining experience and learning new things. So what I suggest to you is that if it's better if you do not set a fixed time. If you start trying to solve problems, and whenever you felt you're stuck, maybe read some part of the editorial. Read some part of the editorial as long as it gives you any idea. You can read all of it, or if you understood, if you got some ideas to think more about it, you can read until that point and then start thinking again. This is what I really suggest to you. And if you want, as I said in those interviews, we talked about these matters in detail. If you want, you can watch them. Hello, brother. I just started doing CP. I know a bit about data structures, but can't solve more than 2-3 problems. What should I practice? And thanks for all these streams. They are really helpful. I'm so happy to hear that these streams that are really helpful for you. I really recommend to you to also join our topic streams as well. Topic streams are exactly for the guys like you. And that's why I felt that it is gonna be helpful. The point is that, you basically need to solve so many more problems and see so many more solutions. That's the main thing that is important. You have to solve so many problems, see so many solutions. What I recommend to you is to, if you're solving 2-3 problems, see what is your current rating. Assume that your current rating is anything. For example, it's 1500, for example. Then go on Codeforces and try to solve so many problems from difficulty around 1500 and 1600. It's even okay if you solve from the difficulty around your current rating. That is completely okay and good. Try to solve so many problems from that one. If you didn't have any idea about a problem, look at editorial, look at the people codes. I looked at a lot of people codes at the beginning when I was training, and that was really helpful for me. It helps me to improve my implementation, and also it helps me to learn so many things by reading people code and learn from them. So what I really explained to you is to try to solve so many problems with difficulty around your rating. If you thought about them for a long time and you felt that you were stuck, it's completely okay to look at the solution, look at people's code. That's okay if you're stuck. At the beginning, it's okay. I mean, this is completely fine. And it would be really helpful for you to get better. I learned dynamic programming, solved some cases, but couldn't solve in contest problem. I don't know why is that, but what should be done for DP even after learning? You have to do so many problem solving, and also you can attend problem solving sessions. I know that some of the people do not have access to classes to problem solving sessions. For DP, for example, we have a dedicated session for DP problem solving. I mean, if I come here, let me share it with you. This is, for example, a session dedicated for dynamic programming problem solving. I solved so many good DP problems. This is gonna be very helpful for you. I mean, this is exactly for guys like you, and this is what I felt that people like you are gonna need, and I started it. I really believe that that's gonna be helpful for you to attend some of the sessions if you have access to classes. I mean, whether you're at school, at university, or you have a teacher, tutor, or anything. Seeing some solutions and finding good problems, these can all help you to get better in problem solving skills. And you definitely, the main part of your practice is to solve so many problems. You have to solve so many problems, and I mean, you have to go to Codeforces, sort the problems, for example, DP problems with some difficulty, and try to think about them. Try to think about them. As long as you have ideas, you find new ideas, that's going to be great. When you didn't have any idea, you can just go over, see people's solutions or editorial to get some idea. Maybe after reading a line, you again have some ideas, you can start thinking again. And this is the way that you can really grow. By this way, over time, you're gonna have experience to face to so many DP problems, and that's gonna help you a lot. How much time should I spend per problem as a beginner? As I said, it's better if you do not set a fixed time. But if you really need to set a fixed time, maybe you can set it at 30 minutes. If you really need to set a fixed time, because you're a beginner. But that's really not a case for when you get, I mean, I had experience of thinking for problems for 10 hours when I was training. I really had experience of thinking on a problem for around 10 hours. But at the beginner level, it's not good to try to start with thinking about the problems for 10 hours. You can start with maybe thinking about the problems for 30 minutes with the situation that you're describing. Expected rating of C. As I said, maybe 1400, 1500, maybe. Nice. Good luck. I hope you have good luck there. Can you share some resources like the roadmap of topics for CP which I can follow as a beginner? I try to make some of them. I try to make more of them roadmaps. Right now I have some guideline videos that I talked about them. Where is it? Let me go over. I have 2 videos about beginners, about newbies. These are 2 guideline videos. These are the things that you should never do if you want to get out of newbie. These are the things that you should do if you want to get out of newbie. I shared these 2 as well. These are the things that you need to know when you start as a beginner, when you start as a newbie, there are some of the things that I really see that in my students. Many times I saw that some mistakes that can really harm their performance. For example, they are newbie, but they try to, for example, learn segment tree, which is very wrong. I mean, when you are a newbie, you should not try to learn segment tree. I mean, you should try to solve so many problems with that difficulty around problems A and B. These are the things. I shared 5 tips, 5 things that you should never do, and 5 things that you should do if you are a newbie. This is gonna be helpful also for greater levels. I'm gonna make videos as well. As I said, I will talk in Telegram and see that what video you want guys to be covered, and I will make videos about those things. And about other resources as well, you can see Codeforces blogs, and for resources for learning, you can look at Yusaku Guide. Yusaku Guide is a very good resource, and things like that. These might help you for other resources as well. What CF difficulty problems I am able to solve in order to clear ICPC regional? It depends that from which region you're going to participate. Some regions are easier, some regions are harder. It depends. You have to see that from your country, which universities, I mean, what are the teams and what are their ratings. So you get an idea that's what is the average rating of people that go to ITCBC from your country, either to regionals or to the world finals. I don't have math strong math knowledge. Is it possible to be good at CP? How much math knowledge required? Math, especially combinatorics and number theory, are important. And we have talked a little bit about math. I've had 3 sessions on number theory, and I also talked a little bit about combinatorics as well. You can find them in topic streams. These are the most important things that you need to think about. You need to know. I mean, it's very good to have a good mathematical knowledge. Mathematical knowledge really helps you to improve at CP. But not all parts of mathematics are equally important. For example, calculus is not that important in competitive programming. But for example, number theory and combinatorics, they are important. Great. I tried a lot of them, but yours are the best. Thank you very much. I'm so happy to hear that. I'm so happy to hear that this is being useful. And that really feels good, and that really motivates me to continue doing this. Do some CF profile review stream someday? Sure. Yes, if you guys think that is helpful, I can do that as well. I can do CF profile review stream. Sure. How can I improve the thinking in right direction? Solve so many problems. That's the main thing. If you want, you can see the interviews that I had with other competitive programs. I shared the link before. The same thing that all of us say is that solve so many problems. That's the main thing. Try to solve problems. If you were stuck, you can look at people solution. You can look at editorial. If you had, again, some ideas, again, start thinking. Solving so many problems is going to be helpful. And attending some of the sessions can really help as well. I mean, that's why we have these problem solving sessions, for example, contest solution discussions or topic streams. Attending these can be very helpful as well, definitely. So because a problem will be shown to you, a tutor comes, he will talk about a problem, and then he will talk about how to think about it, how to solve it. These are gonna help you to build some intuition as well. So if you have access to some sessions, you have a tutor, you have classes in your school, in your university, that's gonna be good. You can attend them. You can also attend these live streams that we have online as well. These are for the objective of them is to reach somewhere that you can build a better intuition on these topics. But other than that, still, I mean, some part of, for example, 20-30% of your time, for example, can be sessions, or even less than that. But still, the majority of your time should be problem solving. The majority of time you should try to see so many problems, try to solve them, get accept from the problem. This is very important. I am expert at Codeforces. I require a lot of practice for reaching Canada. I saw growing competitive programming. I see. Yes, that's good. I mean, you are at a stage that you need to solve problems around your current rating right now, which is experts. I mean, so you know the basics right now. So you have started it, you know the basics, and you are at some good points right now. Now you just need to solve so many harder problems. Now you need to start thinking more about the problems, spend more time on solving problems. You need to solve more challenging problems. You need to, now you are more ready to get to know more complex data structures and so on. Sure, if CF profile review is helpful for you, I will do that. Guys, I think that I'm gonna answer a couple of more questions, and then I guess that's, let me see what time is it. So, okay, let's see that. What is the question? I think I missed your question. I mean, there are some of the questions that I'm trying to scroll up. I think I missed some of your questions. Let's get back here. Do you think anyone can be a good CV programmer? Sometimes I get frustrated also hearing from people just tell me it's possible, man. There are different ideas. For example, Omnic says that anyone can be a grandmaster. I mean, I had a video from Omnic. Let me send it to you as well. There's a video from Omnic that he says that anyone can be a grandmaster. It is his idea, but some other people have different ideas, say different things. So this is the link of the video that Omnic says anyone can be a grandmaster. So, but there are different ideas. But the main thing is that some people get, I mean, tired very soon. They give up very soon, and this is not good. It takes time. I mean, if you look at my own charts, I also was a newbie someday. Look at my charts here. You can see that I was a newbie someday. But a few months after that, when I continued, in here I got rank 4 in a Div 2 contest. And if you want to ask that what did I do in this period between here and here, in this period, I just solved a lot of problems. I went to Codeforces, and I remember that each day I was solving 5 to 10 Codeforces problems each day. I was solving from 5 to 10, and I was not solving all of them myself as well. I mean, when I was stuck, I had no idea on what to do. I was reading people's codes. I usually would not read editorials. I was preferred to read the codes of people, and that's why even right now you see that when I don't have a solution for a problem, I read someone's code and then explain the solution to you. I have a lot of experience in reading people's code and understanding the solution. So basically what I did in this period, for example, this is June of 2015. This is March of 2015. This is, I mean, the gap here is like 3 or 4 months, just 3 or 4 months. And in this period, I remember that this was the best period of my study. I never studied like this later on. I mean, I was just new to Codeforces, and I had a lot of passion. I wanted to solve so many problems. I was seeing so many problems and solving them, and that helped me a lot to get better in Codeforces, and I improved. And the point is that if I would give up when I get to newbie, then I would never be here. I mean, it took me 3 years, two or 3 years to get to Grandmaster. So it's not like you start competitive programming, you study for 2 months and you get Grandmaster. You get a Grandmaster. That's not possible. You cannot get to Grandmaster in 2 months. You have to study for 2 years to get to Grandmaster, for example. So it's important that you don't give up very soon. So when I try to solve someone, let me see that what was the first comment that I did not answer. Will you cover remaining topics number 2? Yes. I want to cover all the topics that I did not cover in the previous ones. I mean, each week we're gonna have a topic stream, so our goal is to cover everything. So yes, we will get back to everything. There are so many things that we haven't covered yet, and we will cover them. Right, so I like to solve too many problems. I get stuck at some problem for a long time, then I watch the tutorial. Then I feel guilty for not able to think about it. That's solving this way is effective. No, that's okay. If you were really stuck, you can look at the editorial. Don't feel guilty for it. Feel guilty if you still could think about it. You still could have ideas, but you didn't think about it and you read editorial. That's bad. But if you are really stuck and you feel that, you're not doing anything useful anymore, it's okay to read the editorial. And you do not really need to read all of the editorial at the same time. You can, as I said, you can read maybe the first line, the first 2 lines, and it gives you some idea of how the solution should be. And then you can think more about it after that. I've been doing a lot of USACO training problems, but they seem quite different over to yes, that's right. The styles can be a little bit different. USACO is very good training as well. I'm gonna start solving some USACO contests as well, either as a topic streams or as videos. I'm gonna solve some USACOs as well. Maybe other than topic streams, I'm gonna have some USACO solve sessions as well. They are very good, but CF also has a lot of graph problems as well. Maybe in the recent problems there weren't many, but in general, CF has a lot of graph problems. Any ideas on specific topics that I might be missing for Codeforces problems? Well, the main important topics are dynamic programming, graphs. It also depends on your current rating. For example, if you are a newbie, I said in those videos that when you are a newbie, the main topics that you need to be okay with the tags are brute force, implementation, and math. When you are a newbie, brute force, implementation, and math. When you get your rating gets higher, for example, you're going to get to expert or something like that, then graphs are important, dynamic programming is important, number theory is important, things like that are important. Then a bit higher than that, data structures, complicated data structures like segment tree, SQRT decomposition, things like that are important. So it depends on your current rating, basically. I guess some people around me just think of money and assets. So let me see. I'm not sure if you're with me or with greed. CP should not be about money. Okay, so you guys are discussing with each other. Keep guiding us for good. Sure. To become expert rated, what rated questions should I solve? I think the best thing is to solve problems around your current rating. If right now you're a newbie, you should not aim for an expert. For example, or if you are whatever you are, try to solve based on the current rating that you have. Try to solve problems based on the current rating that you have. That is going to be very helpful. So, for example, whatever your current rating is, try to solve around that rating. Try to solve problems around that rating. I want to give ICPC, which is in November. So how can I prepare for it? Basically for ICPC, you need to have a lot of team contests. One of the issues that our team had last time is that we didn't have a lot of team contests. We did not participate in contests as teams, and we did not have enough training at all. So you can participate in gyms together. If you are really professionally training for ICPC, the most important training is to participating in gyms, if it's close to your selection. If you want, you can have personal trainings as well. You can, for example, sit next to each other and have a set of problems and try to implement them all together, and things like this can also help as well. For example, you compete with each other sometimes. Sometimes personal training helps as well. But as you get closer to the final contest, it's better to have more gyms and try to practice with one computer and have gyms. Can you make streams for some problems on CSES? If you guys want, I can, yes. As I said, I should set a poll in my Telegram channel to see that what you guys want to be covered. I will choose one of the things that is most popular with you guys. I put the link of the Telegram again. I will choose one of the topics that is most popular for you guys, and I will try to do that. I want to give ICBC wishes in November. Okay, I answered that. Does doing CSES worth or not? Yeah, it is good. It works. Yeah, CSES has good problems as well. But I mean, Codeforces problems are good as well. So maybe someone just solves Codeforces, and that's okay. He or she does not lose anything, even if you just train on Codeforces. But CSES also works. If you have just started, I recommend to you to stick to Codeforces. Don't distract yourself with so many different judges if you just started. But as you go forward, if someone, for example, knows a good problem from CSES and shares it with you, it's good to think about that. How to improve from as a 1200 rated in today's context? I recommend to you, if you are 1200 rated, try to solve problems with difficulty around 1200. That's the most important thing that I recommend to you. Also, if you want, in topic streams, I have discussed different topics like graph, like dynamic programming. I started from very basic. You can learn them as well. That is going to be helpful for you as well. Meta Hacker Cup, I think Arian will stream them, so I think it's not necessary for me to also stream them. Can I make a stream for some problems of CSS problems? I answered that with solving div to quickly take someone to experts. ABC quickly, usually yes. I mean, usually experts solve div to ABC. So solving ABC quickly, if someone solves ABC quickly, he will be an expert. But you do not really need to just train to solve problems very fast. I mean, your main idea, your main goal is to improve, is to be able to solve harder problems as well. I mean, not just solving some problems very fast and not having ideas about the rest. But if you always try to solve problems with difficulty around your current rating or a bit greater than that, this is gonna help you to improve step by step. But yes, definitely ABC, solving ABC quickly takes you just to experts. What time in average to get to a specialist? Several months usually. It takes several months to get to specialist from pupil. It depends that exactly how many months, but you can say that in average 2 or 3 months, for example. Do a FAQ video because so many people ask the same question. That's right. I can do a FAQ video. That's a very good idea. Thank you, Sachin. Bro, how to become a specialist in 2 months? Currently pupil. Solve so many problems. As I said, I told you that. I showed you my plots. This is my plots. I became a newbie, and just 3 or 4 months after that, I won rank 4 in a Div 2 contest. This was my best performance till then. And if you ask me that, what did you do in this period? I opened Codeforces, I went to problem set, I was sorting problems by the difficulty. I mean, back then there wasn't difficulty, there was only the number of accepts. But right now you have difficulty as well. I was sorting difficulty, I was going to the difficulty around my own difficulty, and I started to solve so many problems. I remember that, as I said, I was solving 5 to 10 problems per day. And that was really enjoying for me as well. I mean, I was accepting so many problems. And in that period, I learned a lot. That was my own experience. And this is how I got from here to here. There was a period of time that not only I was practicing a lot, I was really enjoying it because I was getting so many accepts. I was seeing so many new solutions. These were all very helpful. Okay. So yes, how to improve DP as beginner. As I said, you can see, I mean, I'm teaching DP and you can see it in topic streams as well. I mean, I talk about these things in topic streams in DP. I've talked about all these things. So you can watch that in there. I've discussed all these things in the DP topic streams. So great, guys. I'm happy it was a good talk. Maybe tomorrow after the contest we can have these talks as well. We can talk more tomorrow as well. There is a Div 1 and Div 2, a Div 2 contest tomorrow. Oh, I'm not sure that its time is not very good. It's 7 o'clock here when it ends. It starts at 5 o'clock in the morning. So I hope that I can stream it. It's a bit challenging, or maybe I can ask someone to stream it as well. But I try to make this a stream. If no one streams, I will stream it myself. So, thank you very much for joining today. It was again great to have you guys here, and see you guys very soon. How to learn your accent? What do you mean? Sometimes logic is not getting implemented. You can, I mean, it takes time to become good in reading people's codes. Like Sharon Love, thank you. Thank you very much. Love from here as well. I'm not sure if I have to send love from Iran or from the US, but again, love you guys too. My first online judge was Codeforces. Sure, I will make a profile review stream if that is helpful for you. What is your region? What time in your region? My time is right now 2:50 in the afternoon. It's New York time. I live in Maryland, and Maryland is Eastern time, New York time. Thank you guys. Thank you very much. See you guys very soon.